Preparing a small satellite to conduct some big science, an update on our upcoming mission to a metal-rich asteroid, and a new director for the International Space Station. Our Ames Research Center in California is in the final stages of pre-flight preparations of BioSentinel. The CubeSat is one of several secondary payloads targeted for launch on the uncrewed Artemis 1 mission to the Moon with our Space Launch System rocket and Orion spacecraft. BioSentinel will eventually fly past the Moon and into orbit around the Sun to conduct a 6-month investigation on the effects of deep space radiation on yeast, a living organism. This will be the first long-duration biology experiment in deep space and could help us better understand the radiation risks to humans during long-duration deep space missions. The Solar Electric Propulsion, or SEP chassis for our Psyche spacecraft has been delivered to our Jet Propulsion Laboratory in Southern California, where the mission's assembly, test, and launch operations phase is underway. The SEP chassis, built by Maxar Technologies, is the main body of the spacecraft that includes the 6.5-foot wide high-gain antenna and the frame that will hold the mission's science instruments. Targeted for launch in August 2022, the Psyche mission will explore a metal-rich asteroid of the same name located in the main asteroid belt between Mars and Jupiter. Studying the asteroid, which may be the core of an early planet, could provide valuable insight into how Earth and other planets formed. More information about the mission is available at nasa.gov/Psyche. NASA has named Robin Gatens as director of the International Space Station for the agency. She was appointed to the position after serving as the acting space station director for about 7 months. Gatens has 35 years of experience at NASA in both the space station program and in development and management of the life support systems for human spaceflight missions. As space station director, she will continue to lead strategy, policy, integration, and stakeholder engagement for the space station program at the agency level, while working closely with officials at our Johnson Space Center in Houston. According to NASA-supported research, the 2021 Arctic wintertime sea ice extent reached on March 21st tied 2007 as the 7th smallest extent of winter sea ice in the satellite record. This year's maximum extent is 340,000 square miles below the 1981 to 2010 average maximum. For perspective, that is equivalent to a missing area of ice larger than the states of Texas and Florida combined.